6.2, angles and standard positions in all quadrants. So far, we have just really looked at the definitions for standard angles and standard position in the first quadrant. But what happens when we have an angle that's like this? It's in the fourth quadrant. How can we use the reference angle to get what we need, get the information that we need to know about that angle? The most important part of today's lesson is for you to realize that it is so important to figure out what that reference angle is. Calculators are really, really dumb. What they're going to do is they're going to give you only one answer for, say, positive sine. But we know that sine is positive in both the first quadrant and the second quadrant. But your calculator's dumb. So calculators are only going to give you the answer for the lower one, for that one in the first quadrant. So if we were to go with a step-by-step approach, step number 1, what we want to do is find the reference angle, like take away those positive and negatives and just find out what the reference angle. Step number 2 is to figure out in which quadrants solutions are. So if its cos is positive, we know that it is either in the fourth quadrant or the first quadrant. And then step number 3, use that reference angle to figure out where the angle actually is. I wanted us to take some definitions down. So if I were to say that this is my terminal point, we remember from the last lesson, it's going to be r cos theta, r sine theta. Okay? The x-coordinate is going to give you your cos. The y-coordinate is going to give you your sine. Remember, in a unit circle, r is just 1, so it's really easy to figure out what cos and sine is. It's just cos, comma, sine. Great. There's some definitions that I want us to take down, or some formulas. So cos theta equals x over r. Okay, the x divided by the radius. Sine theta is y over r. Tan theta is y over x. You're going to see this next year because we're going to say that tan theta is the same thing as cos over sine. That's a cool little connection. Put in your back pocket for next year. Woohoo! And r is the square root of x squared plus y squared. Guys, all this is doing is saying that the radius, this part right here, is this squared is this squared plus this squared. Like, it's just using Pythagorean theorem, but just isolating that r.